Hello and welcome to my channel, and thanks for coming here. We all need hashing sometime or the other in our programming tasks because we either want to hash our password or we might be wanting to hash some kind of file content, some kind of string to actually understand its identity, to actually preserve the uniqueness. So it's very important for us to actually use the correct hashing algorithm, or rather the most appropriate hashing algorithm. And you know what? The most appropriate hashing algorithm in today's world should be Argon. So in this video, I'm going to show you a quick demo of how we can use Argon online to generate a hash, and then I'm going to share with you a couple of Java programs with which we can use this really modern and very secure hashing technique. So let's get started. So as mentioned by me, Argon is the most modern and the most secure hashing algorithm. In order to first understand it a bit and in order to play with it, please navigate to the site Argon 2 Online, from where you can actually generate a hash, and if you want you can verify it. So I will generate a hash of this input and providing different kind of parameters like salt, parallelism, the memory cost, iterations, hash length, etc. So maybe I will just give an input like this is a test input and I want to generate the hash. The password, the salt has to be minimum 8 characters, I think. And there are 3 variants. The most used variant is Argon 2D because that's pretty fast. The others are a bit slower. So let's try to generate the hash using this button, and then it generates the hash. So if you want to know more about Argon, what you can do is you can go to this link. So as you can see, it has won the hashing competition. Here the details are mentioned there, and this is Argon 2. You can also go to the GitHub repo of Argon 2. That's a C implementation. So it's a native C implementation. If you want to know more about password hashing competition, you might want to go there. Or if you want to know more about Argon, I think there is also a detailed document here. So now I'm going to show you a couple of Java programs where you can actually use the Argon 2 hashing algorithm to actually create a hash, to basically hash your password and then verify it. In order to do that, let us go to my GitHub repo, which is github.com/mshomik78, and under that the name of the repo is hireable coder Java. And if you go there and then please go to the branch, please navigate to the branch which is hashing demo. Where is that? Yes, over here. So if you navigate to the branch, if you open the branch, then you will see that I have provided a very detailed readme, and what I've done in this particular branch is I have given two implementation via which we can actually hash anything in Java. One is a JVM bind, and the link of that is provided here, and the other is using Spring Security Crypto. Very surprisingly, the Spring Security Crypto does not have any other dependency on the Spring framework as such, apart from the Bouncy Castle as well as the Commons logging framework. So let me show you the demo. For you to start with, you'll have to clone my code from here and then do a Maven clean package and then execute the program. I will execute the program from here in IntelliJ. So first I'm going to use this JVM bind directly. So say for example, this was my original password and this is the provided password, and I just want to see if they match. See what's happening here is the Argon is being instantiated, created using the Argon factory, and then the password character array is created and then it is hashed here. So these are the parameters of hashing. You can go and see here in hash and then in the implementation. So the first is iteration, then memory, then parallelism, then the actual password. So if you go back there, so this 2 is the iteration and then this is memory, and then I2 is, again, what was that? That was parallelism. So you can tweak the parameters. So if you increase the number of iterations or if you increase memory, then it will be an even more secure hash, and then you can verify whether the hash matches with the provided one or it does not match. Maybe. So Here when I first ran the program, because since the original password and the provided password were same, so it provided the expected output, it gave the expected output, which is hash matches. Now if I say, for example, give a wrong password, so I'm changing my provided password from the original password, then see what the program will do. So of course the hash will not match, and it will, so it takes a while, and then the hash does not match. So this is using the JVM bind of Argon, and then there is another version of similar program using Spring Security Crypto. So there is an Argon to password encoder which is within the Spring Security Crypto package, and something similar is being done here. So this is the original password, this is the provided password. You can run the program. Here of course it will give hash matches because both are same. And by the way, the Spring Security Crypto is a complete Java implementation, and the beauty of that once again is it does not depend on any other Spring package. So if you go to the POM, then you will see that the Spring Security Crypto has only dependency on this Bouncy Castle provider and also on commons logging. And apart from that, this one is required for the other JVM bind. So that's it. I hope the demo was helpful, but please go ahead and feel free to clone my repo and execute the step. And from the next time when you are using any hashing, you can think of using Argon. If you are still here along with me, then I hope that you have enjoyed my session, and consider subscribing to my channel and watching my other videos for such interesting things which excite me. Thank you and have a nice day.